This is a pattern recognition problem. For such problems, it's useful to start with a small number and examine what pattern emerges. Let's first consider a prime number, for example, 5. Of course, you could also choose another number. The factorial of 5 is the product of the numbers from 1 to 5. And how does the prime factorization look like? It's 2 to the power of 3 and multiply 3 and multiply 5. The factorization ends with the prime number 5. Now, let's look at another example, the factorial of 9. The factorial of 9 is the product of the number from 1 to 9. Its prime factorization is 2 to the power of 7, multiply 3 to the power of 4, and multiply 5 and multiply 7. It's different from 5. The factorization does not end with 9, but rather with the last prime number before 9, which is 7, because 9 is not the prime number. What does the exponent z7 for 2 come from? 2 comes from 2, of course, and also 2 times 2 from 4, and 1 time 2 from the 6, and 3 times of 2 from the 8. In total, this sums to the 7. How does the exponent 4 for 3 arise? Following the same principle as 1 factor from 3, and 1 more from 6, and 2 factors from 9, and the sum of this is also 4. So let's summarize what we observed. So first of all, the prime factorization of the factorial of a prime number ends with that prime number. It's a bit difficult. So for example, 5 is a prime number, so the factorial of 5 ends with 5. So we look at second, the prime factorization of the factorial of a non-prime number ends with the last prime before it. So for example, 9 is not a prime number, so therefore the prime factorization ends with the 7, because 7 is the last prime number before 9. And the exponent of a prime factor corresponds to the sum of the occurrences of the prime in the factorial. For example, the 7 is the exponent of 2. 7 comes from the occurrence of 2 in the factorial. Okay, now let's analyze the given problem. The prime factorization ends with 47. If n is a prime number, then n could be 47. Now, we count how many times 17 appears in this factorization. So one time, of course, coming from 17 itself, and once more is coming from 34. And is there another 17 in 51? We don't know. But now we check an additional condition. This one is hidden. It's just the 13 to the power of 4. So it means there were 4 times of 13 appeared in this factorial. So let's check it. So 13, of course, appears from 13 itself one more time, and one time comes from 26, and again from 39, and finally coming from 52. Since 52 comes before 51, we know that 51 is also included in the factorial. So, which means it also contains another factor of 17. Thus, we conclude that the exponent of 17 is 3. The correct answer is C.